contribution in biomedicine recently. I'd like to talk about biomedicine, how to contribute by chemistry. Biomedicine is defined probably first one, improve human health. Human health includes many kind health system. First, we understand the body works by biomedicine. Second, how disease develop and spread by medicine. How we can treat or prevent illness by medicine. How about biomedicine work on? First, nowadays developing new drugs. Second, developing new treatment for disease. Third, improving public health policies, include biomedicine. Biomedicine nowadays show the advance of regeneration, repairing cells, tissues, organs, body's cellular repair mechanisms. And also nowadays, biomedicine focusing on longevity. Longevity is very now started. Many laboratories in the world activate the body cell for as long as possible, so that people live with fewer disability. And then longevity is very concerned many people. And then third, biomedicine concerned creating new materials, biomedical engineering, stem cells, artificial body parts. Biomedicine included nowadays longevity, chronic disease treatment, and lifespan. And then biomedicine growing up based on the biology, traditionally biology, and the physiological sciences. And now we can use the biomedicine field. We apply supported by computational physics. Now, how to contribute nowadays? Contribution newly and recently biomedicine, and a very bestseller, Harvard University professor, David Sinclair. David Sinclair published is senescence is a disease. Why or why not? It is a bestseller, 2021, 2022 bestseller in healthcare in the world. And that David Sinclair is how old, why we age, where people ages. And then second contribution newly recently biomedicine, telomere. Telomere found by Elizabeth Blackburn, Carol Blythe, Jack Sosda, and Nobel laureates recently. And then 2 years ago, a new biomedicine, CRISPR, well-known Cas9. Cas9 developed Jennifer A. Doudna and Emmanuel Sarpentier. Sarpentier is a French. Blackburn and Sosta, they found that telomere lifespan they received the Nobel laureate awarded. And then also, Taudna and Sarpentier received the Nobel laureates by CRISPR-Cas9. CRISPR-Cas9 is using now your cure very chronic disease, likely so difficult treatment in disease. And Harvard professor, David Sinclair, he published Why We Age and Why We Don't Have to. Bestseller, 2021, 2022, bestseller in the world. Then, now, contribution from changing tool from biology to molecules. In traditionally, this biomedicine based on only cell-based cell. Now, the biomedicine developed molecule, atom and molecules. Our tool is molecule and atom. Recently, biomedicine based chemical knowledge, molecule, from cell to molecule. PCR is a very well known through the coronavirus last 3 years. Coronavirus during the times and then the disease spread worldwide, and we have a very difficult situation. And then we covered and recovered by PCR, very fast detection. And then we have a capability to how to treat the vaccine. Yeah. And then PCR, original name is polymerase chain reaction. This PCR was developed Carol Mullis in 1993. He awarded the Nobel Prize in chemistry. And then also he developed more and more. Nowadays, polymerase chain reaction, he developed more after rewarded Nobel laureates. It is PCR COVID-19 virus test. It is very simple and easy. First, the sample collections. Second, extraction. Third, and we detect COVID or virus RNA detectable very easily. And the PCR chemistry is based on, first cycle, and the second cycle, third cycle, and multiple cycle. And this cycle, first cycle, first the denaturation. Denaturation means protein. Coronavirus is composed of many kind of protein. And this protein, the first denaturation, first process, second process, annealing, and the third final process, extension. Extension is very important because how to detect very can easily, and this process is very important. Nowadays, RT-PCR chemistry is very popular in every hospital in the world. Okay, and then first one step RT-PCR, and the second two-step RT-PCR. Nowadays, many hospitals in the world using now two-step RT-PCR. very quickly test the virus. And the RT and the RT PCR is doing now measurement of mRNA. mRNA is very important nowadays, more than DNA. Coronavirus composed of RNA protein, not DNA. And then this RNA PCR developed also Mullis Nobel laureate. And then measurement RNA expression not done using siRNA. siRNA is a very quick test. Yeah, showing us very clarity, the result. Okay. The coronavirus, this virus composed of so many kind of protein molecules, so many kind of protein, much more 30,000 or 4,000 molecules, protein molecules. And then how to can define and how to can detect. And first, and then we can detect the mRNA, and then it's needed only very quick 48 to 32 hours, only 2 or 3 days detect. It is a very easy and convenient system. If we don't have RT-PCR, and then we waited for many days, about 1 month or 3 months, and then the coronavirus spread whole worldwide. We couldn't wait, and then RT-PCR gives us very easily, very convenient detection. And then use biomedicine is developed in cancer treatment. First, the cancer treatment developed first in 30 years ago. We used the radioactive treatment and the chemotherapy. Radioactive therapy and the chemotherapy have so many kind of difficult, so severe problems, because cancer cell destroyed by chemotherapy or radioactive. However, the normal cell also destroyed. It was a big problem. And then nowadays, cancer treatment developed by immune cell treatment. Immune cell treatment is, developed very effectiveness immune cell of cancer patients. Cancer patients load the immune system. And then immune system cell treatment, basically the blood of cancer patient, blood take out the blood, and then culture the outside, and with another very strong immune blood, including B cell and the T cell. This is called CAR T cell therapy. CAR means chimeric, A means antigen. R is receptor. Chimeric antigen receptor therapy is very now using many hospitals in the world, not chemotherapy, not radioactive therapy. Now, usually CAR T therapy. And then from last year, we can use another cancer treatment called NKT, called chimeric antigen receptor, NK natural killer cell. We have anybody, we have a natural killer cell in our blood, in healthy persons. However, a cancer patient, the natural killer cell very low. And then a cancer patient that organized so. And then now how to take off cancer patient, blood of cancer patient, take off, and then cultured and then healthy natural killer cell, and then cultured after, and then re-infusion to the cancer patient. It is very popular nowadays, cancer therapy in biomedicine. However, this cancer therapy, CAR, CLT, NKT, is only applied, lung cancer, because lung cancer is so-called solid tumor. Movable cancer, stomach or liver cancer, that doesn't work by CAR T therapy. It is a problem. And then nowadays we developed another cancer therapy. Another cancer therapy is we developed in antibody drug conjugate therapy. So we called abbreviated as ADC. ADC is more developed, CAR T, CAR NKT, more than. And then this anti-drug conjugate developed by last year from started, now starting now. Anti-drug conjugate is a different theory, different system, called NKT, CAR T. So different. Why? Anti-drug conjugate, it first developed, collagen. And then we also developed ADC. ADC composed with three components. The ADC molecule with structure using many kind of molecules. First, and seeking tumor cell, and then second molecule is seeking and penetrate the cancer cell, and the third molecule is exploded using payload, and third molecule system ADC, and then we developed we ADC development first we suggested many years ago, is available. We searched many years ago. However, now many 80 years, and then now is applicable. And then ADC development now we registered many patent, and then using now it is necessary to approve by FDA. Yeah. And then before approval of FDA, we have to pass the clinical first clinical test, second clinical test, and finally third clinical test, and then test, and then we applied to FDA USA. And then now, before approval by FDA, we are using now a clinical one step. Now we are clinical testament. And then nowadays, biomedicine developed by gel electrophoresis. Electrophoresis is very, important, by using this, electrical movement. And then we we find out many kind of the DNA molecule by using gel electrophoresis. And then, biomedicine nowadays developed by telomere. Telomere, found by Taudna and Sarfang-Thier, and then by Nobel laureate. And then telomere is rolled in our bodies. So-called telomere is life clock. We have anybody, we have a life clock in human body. The telomere is growing up, and if we have a life, and then we old, getting old, and then the length of telomere shorten, and then to die. Okay, and then we develop also a telomere treatment to the cancer patient. Now, a telomere. Telomere is this is a DNA. The end of DNA here, telomerase. Telomerase is activate telomere, and then the telomere, the length of telomere growing up, going on, and the life is on. Okay, and then nowadays we developed the telomere length and longevity. Longevity based on the telomere length. And nowadays, telomere length longevity very is concerning to cycloastrachenol, rapamycin, compound K. This is suggests longevity molecule. Cycloastrachenol, extract from Aspergillus membranaceous root. This Aspergillus cultivated in the Mongolian sandy soils or northern China borderline, Mongolia. and then it's extracted by uh, uh, special solvent, uh, and then rapamycin also longevity molecule. Rapamycin for you know is longevity, and then another longevity compound K, and I'll show you. This cycloasterogenol, this compound, these longevity molecules from can easily extracted from astragalus. This is astragalus. However, it seems not easier, very difficult, because the astragalus cycloasterogenol you can buy through Sigma Aldrich 1 milligram for and $300 US. 1 million. And then we developed the cycloester high yield, high solubility. And then the cycloasterogenol benefits human body longevity is anti-oxidation, activated telomere, connected in longevity, and improve lipid metabolism and anti-inflammation. And then this cycloasterogenol contributed to lengthen telomere life clock and anti-immunosenescence. Immunosenescence, your aging-free molecule. Anti-pulmonary fibrosis, improve tissue dermatology. And then, firstly, we extracted by astragalus. And then first, we can easily astragaloside form. We cannot get final product cycloasterogen. We couldn't get. Why? It is not included astragalus root. Only this astragaloside 4 transformed to finally cycloasterogenol chemical reaction. We developed this acidic hydrolysis, enzymatic hydrolysis, Smith-Tregeson bacterial in good. And then now we applied so many kind, cycloasterogenol cancer treatment. It is very similar. The longevity molecule is connected to cancer treatment. It is very interesting. Aging is, connected, shortening telomere. Okay? And then second, rapamycin is a longevity molecule, also cancer therapy molecule. Rapamycin was discovered is East Island. East Island, located in the Pacific Ocean in near Chile. Okay? And then many scientists searched for how to find the longevity molecule, how to find the cancer therapy molecule. And then many scientists visited in the East Island. The people in East Island have a long longevity, very long life. Yeah. And then how to they live so very long. And then it is, and then finally scientists finally discovered the soil, the East Island soil is contains the rapamycin molecule. Rapamycin. Rapamycin molecule is a longevity molecule. Is also chemical treated to cancer therapy. Very interesting. Yeah. And rapamycin applied to cancer patient, so the very recovery, very good. Many kind of cancers. Rapamycin, how to react, reaction mechanism. Rapamycin react to mTOR. mTOR, this protein is very important in our life. And then we can find the activation this rapamycin to anti-aging. Also, is treatable to cancer patient. And the last one, nowadays, very developed biomedicine, ginseng to compound K. Ginseng is popular in the worldwide. And then the ginseng is contains so many kinds of saponin. However, longevity molecule and the cancer treatment molecule is compound K. Compound K extract from ginseng. And then we developed how to compound K from ginseng very easily extracted and converted to finally compound K. This is compound K synthesis that we developed. And then nowadays, biomedicine using now very multi-glycotyping, and also we using now computational chemistry. Very early years, we published many kind of computational molecular-based calculation by using GFT. And then nowadays, TFT using developed more and more quantum physics based on. And quantum physics and molecular chemistry, computed drug discovery, very important. We first know the protein 3D structures, and then we can develop the drug for patient, cancer patient, or longevity molecule. It is very important computational drug chemistry. And then, okay, thank you very much. My so-called Korea University Samsung Medical Center, Korea Science and Engineering Foundation. Thank you for your attention.